So myself, Dr.S.DAVID, Assistant Professor, PG and Research Department of Chemistry, St.Joseph College of Arts and Science, Autonomous, Cuddalore. Today we are going to see topic on classifications of nuclides and nuclear stability. First, we have to know what are nucleons. So nucleons is one of the particles of atomic nuclei. Each atomic nucleus includes one or more nucleons. These are surrounded by one or more electrons. They occupy a small space within the nucleus. Every atom is made up of nucleons, which are further divided into electron, proton, and neutrons that orbit the nucleus. An atom is just like a mini solar system, with electron orbit a central star, which is the nucleus composed of nucleons. So nuclear chemistry, it is the study of nuclear change in atom. The composition of nucleus have atom is the smallest particle of an element. It consists of two parts. The central part of atom is nucleus. The outer part is orbit. The nucleus consists of nucleons such as proton and neutron. In atom, number of protons is always equal to number of electrons. Atomic number, it is the number of electron in an atom, or it is the number of proton in the nucleus of an atom. Mass number, it is the sum of number of protons and neutrons in an atom. So the representations of an atom in nuclear chemistry, C represents the element, here A represents the mass number, whereas Z represents the atomic number. So common notations involved in nuclear chemistry. The elements hydrogen with the atomic number 1 and mass number 1, we call the notation as proton P. Whereas the element with the atomic number 1 and mass number 2, we call as deuterium D. The element hydrogen with the atomic number 1 and mass number 3, we call as tritium T. The element helium with atomic number 2 and mass number 4, we call as alpha particle. The elements E, atomic number -1, mass number 0, we call beta particle. The element with atomic number 0, mass number 1, we call as neutron N. The elements with atomic number 0, mass number 0, we call as gamma rays, where otherwise called as chargeless particles. So nuclear size, the formula R is equal to R0 into A power 1 by 3. Here smaller represents the radius of the nucleus, whereas capital A represents the mass number, R0 represents constant 1.5 into 10 power minus 15. Come to classification of nucleus, we are going to see three classifications. First one is isotopes, isoper, and isotones. The elements having atomic number same but mass number different are called isotopes. See here, hydrogen, deuterium and tritium. Here the atomic number having all are same, 1 1 1 for deuterium, hydrogen 1 for deuterium, for tritium atomic number 1, and for hydrogen atomic number 1. Whereas when you see mass number, so there are different mass number. So isotope means the elements having same atomic number but mass number different, we call as isotopes. Second, isobar. The elements having mass number same but atomic number different are called isobar. Here see argon, potassium, calcium. Here in all argon, potassium, calcium, the atomic mass is same 40, 40, 40. Whereas atomic number for argon is 18, for potassium is 19, for calcium is 20. So the elements having same mass number but different atomic numbers are called isobar. When come to isotones, the elements having same number of neutrons are called isotones. So when come to carbon, nitrogen and oxygen, when you separate mass numbers minus atomic number, see for carbon 14.6 mass number minus atomic number, I am getting 8 neutrons. For nitrogen 15.7, 15 minus 7, 8 neutrons. For oxygen 16.8, 16 minus 8, 8 neutrons. The elements having same number of neutrons are called isotones. When come to nuclear stability, the stability of nucleus of an atom is called nuclear stability. The factor affecting nuclear stability of nucleus. First one is odd and even number of proton and neutron. Second one is neutron to proton ratio. Third, magic number. Fourth, packing fractions, mass defect, binding energy. First one, odd and even number of protons and neutrons. Generally, spin factor of nucleons depends upon their odd and even number. Therefore, the number play an important role in stability of nucleus. Even number of protons and neutrons. The nuclei having even number of protons and neutrons are more stable. This is due to the formation of proton-proton and neutron-neutron pair. Example, oxygen 16.8, magnesium 24.12, calcium 40.20. Second, odd number of proton and even number of neutrons or vice versa. The nuclei having odd number of proton and even number of neutrons or even number of proton and odd number of neutrons are less stable. And compared to oxygen 17.18, here oxygen has even number of proton, odd number of neutrons. Examples. The third one, odd number of protons and neutrons. The nuclei having odd number of protons and odd number of neutrons are less stable. Examples, hydrogen, that is deuterium, lithium, boron, nitrogen. Second nuclear stability is we are going to see magic number. The nuclei having 2, 8, 20, 50, 82 and 126 protons or neutrons are very stable. These numbers called as magic numbers. The nuclei having 2, 8, 20, 50, 82, 126 protons or neutrons are very stable. We call this number as a magic number. And come to third one, neutron to proton ratio. In graph is plotted between neutron and proton. It shows a ratio in the range of 1 to 1.6. This region is called a zone of stability. The elements whose n by z ratio lies in range of 1 to 1.6 are stable. If greater than 1.6 are unstable or radioactive. If less than 1 and more than 1.6 are unstable and try to enter into this zone of stability. The elements having N by Z ratio greater than zone of stability has tendency to convert neutron to proton. See here, a neutron is converted to proton plus. The elements having N by Z ratio less than zone of stability has tendency to convert proton to neutrons. So proton is converted to neutrons. Packing fractions. It is the measure of the loss or gain of total mass in a group of nucleons when they are brought together to form an atomic nucleus. The formula packing fraction Pf is equal to isotopic mass minus mass number divided by mass number into 10 power 4. Mass defect. The difference between the calculated mass and observed isotopic mass of nucleus is called as mass defect. Mass defect play an important role to explain the stability of the nucleus. It is denoted by the simple delta m. So mass defect delta m is equal to calculated mass minus observed isotopic mass. Here a mass of proton H is equal to 1.0078 atomic mass unit and mass of neutron N is equal to 1.0086 atomic mass unit. Nuclear binding energy. The amount of energy required to bind nucleons via neutron and proton together in a nucleus is called nuclear binding energy. So it is expressed in milli electron volt. So 931 is conversion factor for atomic mass unit to MeV. So therefore binding energy calculation E is equal to delta M into 931. When come to mean nuclear binding energy, the ratio of nuclear binding energy and mass number is called mean nuclear binding energy. It is calculated by the formula binding energy per nucleon is equal to binding energy by mass number. Finally, when come to the group displacement law, when a radioisotope emit one alpha particle, then its groups or atomic number is decreased by 2 units. And when it emit one beta particle, then its groups or atomic number is increased by 1 unit. We call this as an group displacement law.